Hi everyone. In this video we're going to look at mineral hardness as a diagnostic property. So, in front of me I have your lab kits, and I've taken out 8 minerals at random, each of which has a different hardness. I also have a scratching tool, as you can see here, as well as an unglazed porcelain plate, which we use to determine a mineral's streak. Also, behind me I have the Mohs hardness scale on the screen, starting with talc at number 1 and going up to diamond number 10. So, what is hardness? Hardness is a measure of a mineral's resistance to scratching. A good way to think about it is if two materials interact, one of them might scratch the other one. The one that does the scratching must be harder than the one that's being scratched. So I have a prismatic quartz crystal here, and as you can see, quartz is a very hard mineral. It's a number 7 on the scale, and as a result of its hardness, it's actually resistant to scratching from these other minerals. And even the steel blade, which has a hardness of 5.5, can't scratch the surface of quartz. So if I'm rubbing the surface here, and you can see it's not leaving any marks on the quartz crystal. Now, if I were to take that steel blade and scratch this calcite crystal, which is a hardness of 3, well, the steel blade is much harder, so we would easily be able to scratch the surface of the calcite crystal. And you can see here we can leave these permanent scratches on its surface. So anything softer than a 5.5 on the hardness scale, this metal scratching tool would be able to scratch. Now, it's not only tools that we can use to scratch minerals, we can use minerals to scratch each other. So that same quartz, which is a 7, should easily be able to scratch this calcite crystal. And indeed, when we rub the quartz on the calcite surface, we can see that it scratched the surface. Now, like I said, that calcite is a 3 on the Mohs hardness scale, so anything weaker than a 3 wouldn't be able to scratch it. So if I take gypsum, which is 2 on the hardness scale, and attempt to scratch the surface, well, it's leaving a material behind, but that material can easily be wiped away. It's not actually scratching the surface of the calcite. Conversely, if I take the calcite crystal and I scratch the gypsum, it's going to leave a permanent mark on the surface of the gypsum. Okay? So, we can do the same thing with gypsum. Talc is the number 1 on the scale. It's the weakest mineral, and if we scratch the surface of the gypsum, we might get some powder left behind. But when we take the gypsum and we scratch it along the surface of the talc, we're going to permanently deform the surface, okay? Now, you do need to watch out for that powder being left behind. I have a muscovite here, which has a hardness of between 2 and 3. And if we take the gypsum, which we know has a hardness of 2, and scratch it on the surface of the muscovite, it might look like it's scratching the surface, but it's actually not. That's just the powder being left behind. So you need to be sure which mineral is scratching the other mineral. Now, these nice euhedral crystals provide good facies or cleavage planes which we can scratch. Sometimes the minerals aren't as smooth, so the scratches don't show up as easily. For example, we have a pyrite here, which has a hardness of around 6.25. And if I take the scratching tool and scratch it, now it's not going to do anything because the scratching tool is a 5.5, but even if it was, it might be difficult to see on this surface because it's so chaotic here. But what we can do is use the streak plate and scratch the surface. So as we just saw in the muscovite and gypsum example, the gypsum was weaker than the muscovite, so it was leaving a powder on the muscovite surface. And the same thing can be said for the streak plate. Because the streak plate is harder than the pyrite will leave residue on the streak plate's surface. Now, if we scratch this garnet, which has a hardness of around 6.75 on the streak plate, it shouldn't leave a mark behind because garnet is harder than the streak plate. And as you can see, nothing happened. But if we take the quartz crystal, which we know is a 7, and the garnet, which is weaker than a 7, and scratch the surface, we can see that there's residue left behind on the garnet. Now, another diagnostic tool I forgot to mention is your fingernail. Your fingernail is about a 2.5 on the hardness scale, so therefore it should be able to scratch anything weaker or softer than a 2.5. Now, if we look at our Mohs hardness scale, we can see that gypsum and talc are both weaker than 2.5 on the hardness scale. So if I take my gypsum crystal and I scratch it with my fingernail, sure enough, it leaves a mark on the surface, okay? Now, the only other mineral in front of me here that I haven't discussed is this graphite. Graphite has a hardness of around 2 to 2.5, so slightly harder than the gypsum. As a result, it should be able to leave a mark on the gypsum surface. And as you can see, it does leave a mark. Graphite is another mineral that we need to watch out for though, because it has that sheet crystal structure, which allows it to flake off, leaving marks on almost anything. So if you were to scratch a quartz crystal with graphite, it might leave a mark behind, but it's not scratching the quartz. Okay, so hopefully this video will help with your lab assignments, as well as your understanding of mineral hardness and how we use it as a diagnostic tool to identify minerals.